All right, I'm going to go through the solutions from the AP Classroom questions. So in 1.8, the very first one starts with a calculator question. It asks you, it gives you the rational function, and it says for what values of x does r of x equal 0? So there's actually two ways to do this. One is graph this full function and then see where it crosses the x-axis. The other is, because just the numerator gives us the zeros, is you can just graph that individual function and also see where it crosses the x-axis. So if you do that, you get the blue graph for the original one. I should have switched those colors. Blue graph for the original one, and then the red for just the numerator. But either way, you'll trace where it crosses the x-axis, and you'll get this first one is your negative 2.30. And then the second one happens right at 1, and then the last one happens at that 1.3. So those three answers would be C, negative 2.303, 1, and 1.303. Number 2 says the rational function is given by, and then it gives you the function for what input values of G are the output values of G equal to 0. So think input values are what values of X, and output values are what values of y are equal to 0. So if I would set this equal to 0, and I rewrite my function, this can be, well, actually both of those can be factored. So if I factor that out, I get x times x plus 3, and then I'd get x minus 5 and x plus 4, all in my numerator, and then I get x plus 3, x minus 1, and x minus 2. So before I can find the zeros of the function, I have to make sure I can't simplify it. If we cross through here, that's a hole. So that means that one of my zeros is eliminated. So what's left is 0, 5, and negative 1, which would be B. Number 3 says the rational function r is given by, again, on what intervals is it greater than or equal to 0? So not only do we have to understand where our zeros are, but we also have to understand the pattern here. So if you take out the x in the top, I get x squared plus 4x plus 4. And then that would become x plus 2, and x plus 2 again. And in the denominator, x plus 3, and then x minus 3. So there's no holes or anything. Again, you always want to check for that. We know that our vertical asymptotes are going to happen where the denominator is equal to 0. So negative 3, positive 3. And then I know I have a 0 where this equals 0, where this equals 0, so negative 2, and where this equals 0, again, negative 2, and it's going to bounce there. The other thing I want to check for is my horizontal or slant asymptote. So because this is raised to the third and this is raised to the second, there is not a horizontal, but there is a slant asymptote. And to find that slant asymptote, we're going to divide. X to the third plus 4x squared plus 4x plus 0 divided by x squared plus 0x minus 9. So this would be x to the third plus 0x squared minus 9x. Change your signs. 4x squared plus 13x plus 0. And then I have to multiply by 4. So 4x squared, 0x, 36. Now these don't matter. As long as I change the sign and these cancel, I know I'm good. And this would be my slant asymptote. So I'd go 1, 2, 3, 4, and then my slant asymptote would have a slope of 1. So now I got to figure out where this goes through. Obviously, it's going to bounce at this point and cross through here. So it does something like that. And really, I can plug in a point if I need to understand it a little bit better. I could plug in 1 and see what I get. So I'd get 1 plus 4 over 1 minus 9, which is 9 over negative 8. So that confirms that this is going underneath my axis at that point. And I can also plug in negative 1 to make sure that this is above the x-axis. So negative 1 to the third plus 4, negative 1 squared, plus 4, negative 1, all over negative 1 squared minus 9. Negative 1, this becomes a positive 1, plus 4, minus 4 over 1 minus 9. These cancel. Negative 1 over negative 8, or 1/8. So again, it confirms it's above the x-axis. So I know this part's above the x-axis, and I know at 0 it crosses through, and then it goes below the x-axis. Now I need to know what's happening on the left and the right because I want to know where it's greater than or equal to 0. And remember, it's either going to be in this corner or this corner, and this corner, sorry, or it's going to be here and here. Well, in order for those two to happen, it would have had to cross through the x-axis, and I don't have a 0 there, which leads me to believe it's up here. And then the axis down here, and I didn't do a very good job of going left down, but it would have been more here. And my curve is going to go here. If I'm unsure, like if I did a better job of graphing it, I would have seen it. But if this was, let's say, -4, I could plug in -4 because it's to the left of that vertical asymptote, and it would confirm that that curve is there. So now I'm just looking for everywhere it's above the x-axis, which is from -3 here to 0. So it rules that out, it rules that out, it rules that out, and then from 3 to positive infinity. So D is the only one that works. All right, 1-9 starts with number 1. It says in the xy plane, the graph of the rational function has a vertical asymptote at x equals 4. Which of the following could define f of x? So first of all, I need an x minus 4 to be in my denominator after it's simplified. So if I look at the first one, these are opposites. So they would cancel but give you a -1. Either way, even if 2 cancel, I still have 1 left in the denominator, which means that's an option. In B, these would cancel again. You'd get a -1, but they'd cancel out entirely. In C, 2 of these would cancel here, leaving you with a -1 and 1 of those. So it's gone from the denominator. And that last one, this is a +4, not the x minus 4. So those don't cancel at all. For that first one, if I take out a 4, I get x plus 1. It still doesn't cancel. So the only one that after simplifying leaves you with x would equal 4 in the denominator is number 1. Number 2 says the graph of the polynomial functions f and g are shown. The function is defined by f of x over g of x. What are all the vertical asymptotes of the graph of y equals h of x? So this is another way of rewriting function notation but using graphs. So if f of x goes over g of x, then if I look at the graph of f of x, it would go in my numerator, and the graph of g of x would go in the denominator. Because it wants the vertical asymptotes of the graph, I'm simply looking at my denominator, but I want to make sure it wouldn't reduce first. So the first thing I'm going to do is figure out what the equation of this line is. So this is my b, which is -2, and I can count my slope to here. That's a rise of 1 and a run of 2. So my b is -1, my slope is 1/2. So my numerator would be 1/2 x minus 1. And then your denominator is going to be a function that's quadratic, so it's going to be an x squared, and it has 2 zeros, one at -2 and +3, which means it would be x plus 2 and x minus 3. Even if there was a scale on the front to make that narrow or wide, it could be factored out, which means these are the 2 that we're looking for in terms of zeros. So there would be a 0 at -2 and a 0 at 3, or a vertical asymptote at -2 and a vertical asymptote at 3. All right, 3, I just copy pasted the question at the top. It says, which of the following could be a table of inputs and outputs for the rational function of r given by 2x over x plus 5 squared? So nothing would simplify. This would give you a vertical asymptote at -5. So the first thing I would do is check that, make sure that -5, it's all undefined, which it is. So that could help you eliminate, not in this case, but it could help you eliminate moving forward. So probably the next thing that's the easiest thing that you could do, or what I think that would be a way to look at this, is to figure out what this graph looks like. So at -5, it's got a vertical asymptote. The exponent on the top is 1. The exponent on the bottom would be squared, which means you have a horizontal asymptote at 0. And you have a 0 at 0. Which means that even your curve is going to cross through at some point through that horizontal asymptote. So then the goal would be to figure out what's happening as it's getting closer to -5. Are the values increasing? Are they decreasing? And then that would help you figure out from these behaviors. So if I were to plug in, for example, like -6, I would get 2 times -6 over -6 plus 5 squared, and I'd get -12 over, this is -1 squared, which is 1, and that's -12. So as I know I'm going closer to -5, I'm below the x-axis, which means my curve is doing something like this. And then if I wanted to plug in something like a -1 over here to see what's happening, or even -4 to see what's happening as it's getting closer, 2 times -4, and then -4 plus 5 squared, -8 over 1 squared, so that's -8. So this is also below my horizontal asymptote. So in both directions, I need my arrows to be pointing down. So if I look here, these are both going to -infinity, or they're getting smaller, so it would eventually go to -infinity. Here, they're both increasing, so this is going to be turning up. Here on the left-hand side, as it's coming towards -5, it's increasing, but on the right-hand side, it's decreasing. And for that last one, as it's coming towards -5, this one is decreasing and this one is increasing. So the only one that has the behavior in which they are both going down is A. All right, now let's look at 10. 110 is where we start talking more about holes. It says, which of the following names a function with a hole in its graph at x equals 1 and provides correct reasoning related to that hole? So if I look at the equations that they're giving, the first part is, this is the graph of, and then where is the hole, and then why is that happening? So if I look at this first one, this would be x plus 1 and x minus 1 over x minus 1. And the x minus 1's cancel, so that one does have a hole. So that's one I can come back to. The second one, this is not factorable, so there's not a hole there. The third one, the bottom is not factorable. If I take out the 4 on the front, I get x minus 1, but the bottom's not factorable, so I can cancel that one out. And then the last one, if I take out the 4, I have x minus 1 and x minus 1. It cancels through one of them, but the other one's still there, which means it's a vertical asymptote and not a hole. So even all that rest of that explanation I didn't need because A was the only option, but let's look at the rest of the explanation. It says, because the values get arbitrary close to 2, for x values sufficiently close to 1, but the function's undefined at 1. That 2 would come from plugging the hole back in. So if the hole's at 1, I would have gotten 1 plus 1, which is 2. So on both sides, they will get arbitrarily close to 2 without actually touching it because it would be undefined. All right, go to number 2. It says the rational function r is given by x squared minus 4 over x squared minus x minus 2. The table gives the values of r for selected values of x. Which of the following statements is true? So I pasted in the statements from the next question just so it's on one screen. But let's take this function and let's break it down. So it'd be x plus 2 and x minus 2 over x minus 2 and x plus 1. So my x minus 2's are going to cancel out, which means there's a hole at 2. It'll be happening around here. So the answer choices are all talking about the limit as it's approaching 2. So notice it says as it's approaching 2, as it's approaching 2, as it's approaching 4 halves, and as it's approaching 2 from the right. Well, I know that as it's approaching 2, it would equal the other side of your y. Or it would equal the value of what you would get for when you plug in y. So I'd get 2 plus 2 over 2 plus 1, and I'd get 4 over 3. So that y value is going to be 4/3. But here's where it gets tricky. So if you look at these answer choices, both A and B say the limit as it approaches 2 is 4/3. And that part's correct. But the second part says r of 2 equals 4/3. Well, r of 2 would be undefined. If I took 2 and I plugged it into my original equations here, r of 2 is actually undefined. So I can't say it equals 4/3. But it does say it's undefined at x equals 2, so the graph has a hole at 2 and 4/3. So on my physical graph, there would be an actual hole at that point, which means it's not defined there. And that's why B is the better choice. If you just look at the other ones, this has flipped. The 4/3 is in the x, and the y is the r of x is now 2. And then if you look at the last one, it says as it approaches 2 from the right, it goes to positive infinity. Well, this is a hole, and this hole means it's going to approach that 4/3, not positive or negative infinity. Okay, looking at number 3, it says the rational function g is given by x to the third plus 1,000 over x squared minus 100, which is broken down for you. So they actually took and they broke this down by factoring that perfect cube. Perfect cubes are something that you definitely need to review. So remember, you would cube root, and then it's the SOAP when you expand it. So it'd be x plus 10 and x squared, change the sign so it's the opposite, 10x, and then make it positive 100. And that would go over x plus 10 and x minus 10. So then it says, which of the following statements describes the behavior of g? Well, if you look here, these can cancel out, which means there would be a hole there. So I know there's a hole at x equals negative 10. If it asks about vertical asymptotes, it would come from here. There's a vertical asymptote at x equals positive 10. So when you look at the A statement says graph intersects the x-axis at negative 10. That's false because there would be a hole. B, the graph has a hole at negative 10. That is correct because both the numerator and the denominators are factored. It appears only once. C says the graph has vertical asymptotes at 10 and negative 10. Well, there's not one at negative 10. It's a hole, so that one doesn't work. And the graph has no holes because the degree of the numerator is greater than the degree of the denominator. That is not how we test for holes. B is the correct answer. Okay, that wraps up that AP questions. You're going to definitely want to look over these and your review before your test.